Welcome to the Bodhi Academy. My name is Amisha Kulaso, and in today's video we will continue with our chapter Rational Numbers Class 8 Chapter 1. So previously in this chapter we spoke about the closure property, and we categorized it in different operations. That is, first we spoke about addition, subtraction, multiplication and division. Next we went to the integers part of it, and lastly we discussed the rational part. So in today's video we will be discussing two more such properties, that is the commutative property and the associative property. So let's start with the whole numbers. Now, so the first one we have the addition operation, and say we have numbers 0 plus 7. Now in commutative property the general formula is A plus B should be equal to B plus A. So say I have A and B as two whole numbers, then if I change the order of addition, if I add B first and then I add A, in that case the answer should remain same in both the cases. That is the general formula for commutative property. Now let's look at addition. So addition of whole numbers we know it starts from 0 and it goes on. So say I have 0 plus 7 and I have 7 plus 0. In both cases it is going to be equal to 7 itself. Next say I have 2 plus 3, that will be and next the reverse of it will be 3 plus 2, and in both cases my answer will still remain 5. So in that case what we can say, for any two whole numbers A and B, A plus B is always equal to B plus A. Therefore addition is commutative. Now let's go and look at subtraction. Now say let's take the same example, or let's take this one, 2 plus 3. So you have 2 minus 3 equals to 3 minus 2. Now in this case see, in the first case when you have 2 minus 3, your answer will be minus 1. Now you are changing the numbers. So 3 minus 2, in this case you will get 1 over here. So what is happening? Our answer, final answer is changing. So therefore 2 minus 3 is not equal to 3 minus 2, and therefore we can say subtraction is not commutative. Next let's look at multiplication. So say I have 2 into minus 3 and I have minus 3 into 2. Now in these both cases, so when I have first 2 into minus 3, answer will be minus 6, and then say I have minus 3 into 2. Here again answer will be minus 6. So therefore again what we can say, that multiplication is commutative, because in this case the answer will remain for both as minus 6 itself. Next let's look at division. Now say I have here 2 upon 3 divided by, this will go reverse, 3 upon 2. Now the answer here for 2 upon 3 and 3 upon 2 will be different. Say I am doing 3 upon 2. So in this case what I'll start with 0 and I'll put here 0 another. So this becomes 20. So 18 and 6 you get 2, and then it is going to be reoccurring in this case. Now I have 2 divided by 3. In this case I'll start with this, I'll get this, and answer is 1.5. So the answers are different. For one I'm getting 0.66 and for the other I'm getting 1.5. So therefore we can say, this is equal to sign. 2 divided by 3 is not equal to 3 by 2, because in 2 by 3 we get the answer as 0.66, and in 3 by 2 we get the answer as 1.5. So therefore both are not equal, and therefore division is not commutative. Now let's check the same for the integers property. Now say I have over here for addition, let's look at it, like I have minus 5 and plus 3, and the other way round it would be 3 minus 5. Okay, so here the sign of 3 is plus 3, same as it is here, and sign of minus 5 is minus 5 here. So now say I have minus 5 plus 3, answer will be minus 2. Then say I have 3 minus 5, again answer will be minus 2. Therefore here in both the cases my answer will be minus 2 itself. So therefore addition is commutative. Now subtraction. So say I have minus 5 and minus 3. So I have 5 minus minus 3. In this case what will happen? This minus minus becomes plus. So 5 plus 3. So 5. So 8 will be the answer over here. Now the second way round is minus 3 and minus 5. In this case what I will get? This will be again plus itself. Minus minus will be plus. But the answer will have a negative sign. So this and this are not equal, correct? So this and this is not equal. So therefore subtraction is not commutative. Now let's look at multiplication. So I have say 5 into minus 3, and I have, here's one mistake we have done. Okay, I have done one mistake, that is this had to be whole numbers, so they are only going to be positive numbers. Okay, so either way round the answer will be 6 only, correct? Okay, so that was one correction. Now here for integers, now say I have a positive and a negative number, and we do the reverse of it into 5. So in this case what it will be? It will be minus 15, correct? So in both the cases I will get minus 15. 5 into 3 15 and minus sign, 3 into 5 again 15 minus sign. So multiplication is also commutative. Now let's look at division. So say I have minus 1 upon 3 equal to 3 upon minus 1. Now these two are not equal. 3 upon 1 will be what? Minus 3 itself. Say I have 3 upon minus 1. 1 in the denominator does not have a value. So therefore it becomes minus 3 itself, correct? And minus 1 upon 3 will have some value in decimals. So therefore they are not equal, and therefore division is not commutative. Now let's go ahead and look at the rational numbers. Check for commutative property for rational numbers. Okay, so now say let's start for addition. In the first example, so we have minus 2 upon 3 plus 5. So the answer that we get is 1 upon 21, and say 5 upon 7, you are going to exchange this. So 5 upon 7 plus minus 2 upon 3 will be again minus 21. So let's try to solve it. So minus 2 upon 3 plus 5 upon 7. Here we can remove LCM, or we can simply cross multiply. So we'll get 7 2s are minus 14 plus 15 upon 21. So in this case it will be 1 upon 21. Now let's look at this part. So 5 upon 7 plus minus 2 upon 3. This will be equal to, again we can simply cross multiply. 5 3s are 15 minus 7 2s are 14 upon 21. So again answer will be 1 upon 21. So therefore rational numbers for addition we can say they are commutative for each other. Now let's look at subtraction. So we have 2 upon 3 minus 5 upon 4, and we have 5 upon 4 minus 2 upon 3. Now let's solve this. So 4 2s are 8 minus 5 3s are 15 upon 12, and this will be 5 3s are 15 15 minus 8 upon 12. So it is very obvious, in one answer we will get a negative sign. So 8 minus 15 will be 6. So we'll get minus 6 here, and over here we'll get a plus 6. So the answer is clearly different. One place we are getting negative, one place we are getting positive. So therefore this subtraction is not commutative. Then let's check for multiplication. So we have minus 7 upon 3 into 6 upon 5. Answer 7 6 is 42, minus 42 upon 5 3s are 50. And if I reverse it, 6 by 5 into minus 7 upon 3, again minus 42 upon 50. So therefore the answer is same, and therefore it is commutative for rational numbers. Division, it is very easy that it won't be commutative. Minus 5 upon 4 divided by 3 upon 7. This won't be commutative to the other way round, because the minute you change one number or you reverse the order, one will come in a decimal number and the other one will come into a probably a rational number or a whole number. So therefore division is not commutative. Now let's look at the associative property. So associative property, the general formula is like this. So the general formula, okay, it is A into bracket B into C will be equal to A into B into C. Just the bracket for the given two numbers are changing. So let's try for addition first. Say I have 2 plus 3 plus 5, okay, equals to 2 plus 3 plus 5. Here we are not changing any, there is no interchanging of numbers that is happening, only the brackets are interchanging. So in this case the answer would be what? 5, 8 and 10. And here also, even if I do this, this will be what? 6, 3, 5 plus 5, that will be equal to again 10. Therefore addition is associative. Now let's look at subtraction with the same example. So 2 minus 3 minus 5. So I have this, and the other way around would be what? 2 minus 3 minus 5. Okay. So 2 minus, this would be minus 2 equal to minus 1, and this is minus 5. So this will become plus 2 plus 2, and this will become, this will remain as it is. This will become 4, and here we'll get minus 1 minus 1 minus 5 minus 1 will become 6 and minus 6. Therefore it is not equal. Therefore subtraction is not associative. Multiplication, it will be associative because we are just multiplying the same numbers, correct? So therefore even if you multiply it in any given order, the multiplication answer will remain the same, or the product will remain the same. Therefore multiplication is associative. Then we have the division. So division, let's take an example. Say I have 2 by 3 divided by 2 by 3 divided by, this will be 3 by 2 divided by 3 by 5. Okay. So in this case I'll solve this bracket first. So I have 2 by 3 divided by 3 by 2, reciprocal I'll take 5 upon 3. This will be 3 will go off. So 2 by 3 divided by what will be left? 5 upon 2, correct? So therefore this final answer I'll get something be 2 by 3 into, it will be 2 by 5. So this is 4 upon 15 that I'm getting. Now let's look at the other way round. So other way round would be 2 by 3 divided by 3 by 2. So we'll get a bracket and division 3 by 5. So in this case 2 by 3 into 2 2 by 3. So divide by 3 by 5. So 2 2s are 4 upon 3 3s are 9. Divide by 3 upon 5. Again 4 upon 9 into 5 upon 3. 4 5s are 20. 9 3s are 21. So 20 upon 21 and 4 upon 15 are different. Sorry, this is 27. So these answers are completely different from each other. Therefore, division is not associative. Okay. Next, let's look at the integers part of it quickly. So see now, here we have minus 2 plus 3 plus minus 4. So here the answer will be what is right, minus 2. This will become minus 1 and minus 2 plus into minus. This is plus into minus, minus 1. So answer will be minus 3 here. Now let's look at this one. Answer will be 1 plus into minus, minus 4. Answer will be minus 3 here. So addition is associative. Second, let's look at subtraction. So the answer to this 5 minus 7 minus 3. So 7 minus 3 will be 4 minus 5, that is 1. Other way round, 5 minus 7 minus 3, that will be minus 2 minus 3. So answer will be minus 5. So here answer is minus 5 and here answer is 1. Correct? So therefore subtraction is not associated. Multiplication, we know already, no matter in which order do we multiply, the multiplication is always going to be associated. Division, so say minus 10 upon 2 is there and then we have divided by minus 5. So this will be 5 and this will be minus 5. Divided by minus 5 will be 1. Other way round, 2 if you divide by minus 5 and divide by 10. So this if I take, okay, this I will take reciprocal 10 into 2 upon 5. So 20 upon 5. 5 ones are 5, 4's answer is 4 over here. And the answer is 1 over here. So therefore it is not associative. Okay, rational. Now let's look at the rational numbers. So we have minus 2 upon 3 plus 3 upon 5 plus minus 5 upon 6. So we can solve this part first. On solving this part we get minus 7 upon 30. Then if you solve it with the rest remaining part, the final answer that we get is minus 27 upon 30. This on further cancellation, this is 9 and 3 9s are 3 10s are. So answer comes to minus 9 upon 10. Now if you change the order, if you shift the brackets, the answer still remains minus 9 upon 10. Therefore we can say that these two are associative. Okay. Then subtraction, obviously it won't be, because the minute we already know that the minute you shift a bracket, the signs are going to change and therefore the answer will not remain the same. Multiplication, no matter in which order you multiply or where you shift a bracket, the final answer still remains same. Therefore it falls under the associative property. And division, lastly, we know that it is different in all the cases, because when we shift the brackets, the signs also shift, as well as some answers come in the form of decimals, whereas the other come in the form of whole numbers. So that was it for today's video. Please don't forget to like, share and subscribe to the Bodhi Academy.